Let us start this lecture with a thought process from great saint Swami Vivekanand, who says that every person is potentially divine. The objective is to manifest the divinity within by controlling nature external and internal. This is really one of the very profound statement which was taken from Vedantic literature and which is very important even today, and that can motivate us to manifest the divinity which is lying dormant in within us. So, let us recall what we learned in the last lecture. In the last lecture, we discussed about the liquid propellant, and liquid propellant was classified into broadly into two categories. One is hypergolic propellant, other is non-hypergolic propellant. In case of hypergolic propellant, the fuel and oxidizer will be self ignite, and it again divided into one is simple, other is or the monopropellant, one is other is the bipropellant. And in case of hypergolic propellant, it is one has to provide ignition energy for the initiation of combustion. It can further divided into two categories, one is monopropellant and bipropellant. In case of non-hypergolic propellant is again classified in two categories, one is simple, other is the mixture. So, and later on we also classify the propellant based on energy level, that is basically low energy level, medium energy level and high energy level. Here energy level we mean basically the range of specific impulse. And later on also we again classified based on the storability. The liquid propellant was divided into two categories, one is earth storable, other is space storable. Later on also we discuss about the various kinds of oxidizers and fuels which can be used, and some of them are used even today. And later on we move to discuss about fuel and oxidizer combination pertaining to the liquid propellant. And today we will be starting a discussion on solid propellant rocket engine. As most of you will be aware, the solid propellant rocket engine is very old. It was basically started in China with the gunpowder, and later on it was moved to the India and other countries, and but at that time the propellant was only gunpowder. Later on of course, we have developed a lot of exotic and high performance propellants that we had discussed in last few lectures. A question might be coming to your mind, what are the applications the solid propellant can have and why it is important to be used. Let us look at some of the applications of solid propellant rocket engine. Keep in mind that the rocket engine is sometimes is known as also rocket motor. So, we will be using this engine and motor interchangeably in this course. As I mentioned earlier, the solid rocket engines are basically used as a booster rockets which can be strapped on to the main rocket engines, particularly for the space launch vehicles. It has been used in our PSLV, JSLV and other engines. And booster rocket means basically it can provide high thrust for a very limited time, and that is the beauty of the solid propellant rocket engine, is that it can provide a very high thrust, although its specific impulse is in the lower range as compared to the liquid propellant rocket engines. In modern time also, it is being used as a upper stage propulsion systems for orbital transfer vehicles, because of fact that one can store the solid propellant for a longer period of time, and also it is very simple to design. And beside this spin and de-spin system for the spacecraft, it is being used. And solid propellant rocket engines are used for strategic and tactical missile propulsion system, because it is of simplicity and one can operate it at any time. There is no gestation period for firing a solid propellant rocket engine. And these engines are also good candidate for as a gas generators for starting of liquid rocket engines, pressurizing liquid propellant tanks, and any other place wherever it is required. And let us look at a typical rocket engine which is shown here. You can see that it is having various components, and the main components are, you can look at is the casing. This is your casing part in which the propellant charge, we call it as a also grain, is being housed, and it is having also igniter here somewhere in this region, the igniters, which is meant to initiate the combustion of the solid propellant. So, therefore, in case of the side burning propellant grain, it is placed on the aft side of the propellant, and on the other side it is having a nozzle. Of course, the seal has to be used properly, otherwise there will be leakage of the gases from this combustion chamber of the solid propellant to other. So, nozzle plays a very important role, because in this nozzle the high pressure and temperature gas is expanded to produce the requisite thrust. Let us ask a question, why the solid propellant rocket engine is sought for or sought after? And as I told earlier, that it is very simple to design, fabricate, and also its reliability is quite high. So, therefore, it is being used for various applications, and beside this one can also have a solid propellant rocket engine for a very small size to a very large size in terms of thrust. Of course, its specific impulse is little lower as compared to liquid propellant rocket engine. Let us look at what are the characteristics of a solid propellant rocket engines. So, as I told earlier, solid propellant rocket engine is basically a very simple system. Of course, it produces a medium level of specific impulse starting with 160 to 320 seconds, and disadvantage of the solid propellant rocket engine is that the fuel and oxidizer cannot be really controlled. In other words, one cannot throttle the fuel and oxidizer, any one of them even, as it is routinely done in the liquid propellant rocket engines. That is the disadvantage of the solid propellant rocket engine. Beside this, the burning rate depends on the chamber condition, like pressure, chamber pressure and temperature, and also the propellant composition. And propellant composition can be really fixed once it is propellant grain is designed. As I told earlier, that it can operate over a wide range of thrust 2 Newton to 5000 kilonewton or the 5 meganewton, and some people are claiming one can also get a very higher thrust solid propellant rocket engines. It can go up, thrust of the solid propellant rocket engine can go up to even 10,000 kilonewton. So, let us look at little more characteristics in terms of data and compare with the liquid propellant rocket engine as shown in this table. So, if you look at the storage wise, the solid propellant rocket engine is quite stable, which can even for 10 to 15 years. As compared to the liquid propellant rocket engine, the propellant will remain stable both chemically and thermally only for 1 to 2 years. That is the reason why the solid propellant rocket engine is really sought after for making the missiles and also the certain space applications where the propellant has to be stored in the rocket engine itself. And the burning rate of the propellant in case of solid propellant rocket engine is quite low, of course, as compared to the liquid propellant rocket engine, and chamber pressure of the solid propellant rocket engine is quite high, which varies from 1 megapascal to the 70 megapascal. 70 megapascal means around something 700 atmospheric pressure, and whereas the liquid propellant rocket engine chamber pressure varies from 0.3 to 10 megapascal because of limitation of the combustion chamber thickness. In case of liquid propellant rocket engine, the casing of the combustion chamber will be exposed to the high temperature and pressure gases produced due to the combustion all the time. In case of solid propellant rocket engine, the combustion will be taking place inside the propellant itself, particularly in case of the side burning propellant grain, and therefore, the pressure will be experienced by the propellant, not by the wall of the combustion chamber. And as a result, the chamber thickness in case of solid propellant rocket engine will be very, very small, and as compared to liquid propellant rocket engine. As I told earlier, it is mostly used for the booster, but with the modern development of the exotic propellant, solid propellant, it can now be used as a sustainer as well. But whereas the liquid propellant rocket engine is generally used as a sustainer, very rarely as a booster, and thrust one can get a very low values to the very high values. As I told it, one can get a thrust in case of solid propellant rocket engine from 2 Newton to even 5 mega Newton, and whereas the liquid propellant rocket engine will get a very low thrust. And keep in mind that also the thrust coefficient in case of solid propellant rocket engine is quite high, because it will be operated at a higher chamber pressure, and the reliability of the solid propellant rocket engine is quite high. It will be greater than 99%, and whereas the solid propellant rocket engine will be quite, the reliability of solid propellant rocket engine is quite low, because of fact that it will be containing several components. If any of the component will fail, that means the liquid propellant rocket engine system itself will be failing. And solid propellant rocket engine design is quite simple, and as compared to the liquid propellant rocket engines. So, therefore, the solid propellant rocket engine is considered to be very important, particularly for the booster engines. Let us look at what are the application of solid propellant rocket engine a little bit again, just to make it a point that it can be used in the spacecraft, in missile. It also can use as a research aircrafts, giving the initial velocity to the supersonic vehicle like scramjets. Generally, the rocket engine is being used. It has been used in India for indigenous development of the scramjet engine. And beside this, solid propellant rocket engine can be used as a retro rockets. A retro rocket means basically the rocket is to be fired in the opposite direction of the motion of a vehicle, and this is very much essential if you want to land easily without any damage on a particular earth, particular as the space craft will be moving at a very high velocity. You must reduce it by using the retro rockets, and also you can it can be used for the landing of the even aircraft in a very short runway. And beside this, the solid propellant rocket engine is used as a gas generator. As I told, gas generator is a very important component even in for the pressurizing the gas tank in liquid propellant rocket engines and other places, and it is also can be used as a igniter and material delivery system. And if you look at, like, if there is a ship which is affected by the tornado, which is not accessible to there, and in that case one can really send the relief by using the solid propellant rocket engine. And solid propellant rocket engine can be used for attitude control and signaling even, and ejection of the crew escape capsules, which has already been used, and it can be used as a sounding rocket for measurements of properties in the atmosphere, look at the condition of the atmosphere, and it can be used as a spin rocket particularly for the in the spacecraft and where you can have to control. Therefore, it can find several applications. Even nowadays people are contemplating to use the solid propellant rocket engine is in the submarines, and even in torpedoes it is being used to attack a submarine, and several places the solid propellant rocket engine can find application. That depends on the imagination of the user and also its design and development will be changed according to the requirement. So, therefore, it is important to study the about the various aspect of the solid propellant rocket engines, and let us now compare a little bit the solid propellant rocket engine with respect to the liquid propellant rocket engine. As I told earlier, the solid propellant rocket engine is quite simple with few moving parts, whereas the liquid propellant rocket engine is quite complex with several moving parts. And as I told earlier that it can be fired on quick demand, as there is no need to pack the casing with solid propellant, because already solid propellant can be stored housed in the casing, so that it can be fired easily. And of course, the liquid propellant engine cannot be fired quickly, as the tanks have to be filled with liquid propellant, as storability of the propellant is quite limited. So, it delivers very high thrust levels, more than the 5 meganewton, as by simply having a large enough nozzle to expel the large mass flow rate required to attain a high level of thrust without significant design compromises. But in case of liquid propellant rocket engine, for getting the higher thrust is limited due to the restriction in design of turbopumps, because of that it cannot be really operated at a high pressure. And of course, in recent time several liquid engines are being developed to achieve higher thrust, but with penalties such as higher inert mass and also other complexities involved, and the tank will be very high. And the solid propellant rocket engine cannot usually change the thrust in response to the current condition or be test fired without expanding itself, because of throttling is not that possible. But however, in recent time there is a way of terminating it, and also one can change it. You can get a pulse rocket by using different varieties of the solid propellant gains. Liquid propellant engine can be throttled and turned off very easily, because you can control the fuel flow rate and oxidizer flow rate by controlling valves. Solid propellant engine can also be used in orbital test vehicles to raise a payload from low earth orbit to a higher earth orbit, as they have higher density impulse than the liquid system. Although a solid orbital test vehicle is higher than the liquid, and hence its lower volume has advantages in small places. So, these are the broad differences between the solid propellant and liquid propellant rocket engines. Each one is having their own advantages and disadvantages. So, one has to basically use depending on its applications and maximize the advantages, so that they are being used. That is the reason why solid propellant rocket engine is used as a booster, whereas the liquid propellant rocket engine is used as a sustainer in case of space vehicle. So, let us look at the solid propellant rocket engine little further, and what are the components of solid propellant rocket engine, which is very critical, and also we need to look at it. Let us look at a cross section of a solid propellant rocket engines. You can see that if you take a cross section of this here, A to A cross section looking like that, and this is having a casing here, and this is casing is that contains, that houses the solid propellant grain, and casing is generally made of high temperature or the low weight and high strength metal, particularly aluminum alloys, and also the recent time composites being used as a casing material. And the solid propellant grain which is being used, which is shown as here, it will be packed in the in this casing, and this is if it is being packed in this housing, then we call it as a case bonding propellant grain, and which is in between the solid propellant grain and the casing, there is a layer which you call it as a insulator, a liner, and liner is basically is used such that it can arrest the heat transfer during the combustion to that, whatever the heat will be transferred that. So, it will be act as a insulator, and beside this it will be helping the propellant to be packed properly such that it will not displace when this rocket engine is subjected to acceleration. Therefore, this is a very important component, one has to take care of it, and beside this igniter is always will be on the upside of the side burning grain. This is a side burning grain, and because the combustion will be taking place here in this zone, these are the regression surface, and for to initiate the combustion on this on the surface of this solid propellant rocket engine. So, generally the igniters is placed on the upside of the rocket engine, so that it can provide enough energy to initiate the combustion, and so that the entire surface area, this is your inner surface of the portion, surface area of propellant grain, the entire surface of the propellant grain must be ignited such that the flame spreading will be there on the entire surface. And beside this, it is having a nozzle, and this nozzle we will be having also a insulation which is not shown here. There will be some layer of insulation. This is the so that heat transfer can be arrested, and nozzle plays a very important role because it really produce a thrust when the high temperature, high pressure gas, when this high temperature, pressure and temperature gases will be high pressure and high temperature gases will be expanded in this nozzle, you will be getting thrust. And beside this, to initiate a combustion, a nozzle closer is being used to start with, and this is known as a nozzle closer. Particularly a very large engine it is required, and beside this there is a thrust terminator port is being used whenever you want to stop the operation of the rocket engine during its flight. What you need to do, that you will open this port and such that the gas will be coming out, and then pressure will be reduced, and you can really stop this operation of the rocket engine. This is a thing which is a new addition. So, let us look at the side burning grain, and it is having a limitation, that means burning will be taking place in this direction, and this is known as end burning grain. And it is having a casing, of course, this having a insulator, this is a inhibitors or insulator kind of things, this is your insulators, and igniter is located little near the nozzle or the exit such that the gases will be coming over here, and it will be spreading over this burning surface. This is your burning surface, and of course, there is a diaphragm or the nozzle closer which is required such that the chamber pressure can be built up very easily, so that it will not undergo any pressure fluctuation during the initiation of the combustion. This is your end burning grain, and when you compare the end burning grain with the side burning grain, then you will find that this is having limitation, the burning surface is limited by the diameter of the end burning rocket engines. So, therefore, it is being used for a very limited applications. With this I will stop over here, and we will be discussing about the mechanism of the solid propellant combustion in the next lecture. Thank you very much.